We're going to do a second problem with a heparin protocol. Let's take a look at our problem. The physician has ordered an initial dose of heparin for your 212-pound patient as follows. Initial bolus is 60 units per kilogram, initial infusion 14 units per kilogram per hour. As we look down through the problem, we're going to be finding units and milliliters for that initial bolus. We're going to be finding units per hour and milliliters per hour for the initial infusion. And then we have a first APTT value and a second APTT value. Let's take a look at the next slide where we have the images for our meds and our protocol. When we take a look at our meds, we have a vial here, and this would be used for our bolus. I look at the strength here and I see that it is 10,000 units per milliliter. I have an IV bag. This would be used for my IV drip. And I see that it has a reduced fraction here for the strength of 50 units per milliliter. The initial infusion rate is to be 14. I again have this maximum initial rate not to exceed 1,000. So let's go back and start the math. First thing that I'm going to do is convert my patient's weight from pounds to kilograms. So I'll take 212 and I'll divide by 2.2 because there are 2.2 pounds to every kilogram. And for my answer, I get 96.4. I am rounding that to tenths because the weight is more than 10 kilograms. Now I'll start with the bolus. The bolus is to be 60 units per kilogram. So 60 units per kilogram. I will multiply by the patient's weight of 96.4 kilograms. Cancel my kilograms, and I will do this math on the calculator because it will give me an answer in units, which is one of the answers that has been requested. So on my calculator I multiply and I get 5,784, and that is units. Now I'm going to continue, even though this is one of the answers I want. I'm going to use my med to convert this over to milliliters. So I know that units will go in the denominator, milliliters in the numerator, and I think that it's 1,000, but let me just double check. Yes, our bolus med has a strength of 10,000 units per milliliter. So I can go back and use that to do my conversion. So 10,000 per 1 ml. This allows me to cancel the label of units. Do my math on my calculator. I get 0.5784, and I'm going to round to hundredths. So I end up with 0.58 milliliters for the bolus. So I would pull that into a syringe and give that as an IV push. Now I get to move on to the initial IV drip, the initial infusion. And so I have my beginning information here as 14 units per kilogram per hour. So 14 units goes on the top. Kilogram and hour both in the denominator. And again I'm going to multiply by the weight to cancel the kilograms. So 96.4 kilograms. So kilograms cancels. And I go to my calculator and I get 1,349.6 units per hour. So I want to look at my protocol, make sure that that is under the maximum, and I also want to look at the med that is available for the IV drip. So the maximum initial rate is not to exceed 1,000. Ooh, we were at 1,349.6, so we have a problem there. The med has 50 units per ml. So let's go back and talk through what we're supposed to do. We are not allowed to exceed 1,000. And so we cannot give this 1349.6. So do not give. Instead, we want to go with the maximum. And that is why we have the set of directions to tell us what to do. So instead of going with the 1,349, I'm going to restart my problem with 1,000, that was the maximum, units, that was not per kilogram, that was just units per hour. So this is how many units per hour I'm going to give my patient, and then I do have to convert that over. We had just looked at our med. Our med had a reduced fraction where it was 50 units to a milliliter. So we cancel the label of units, we go ahead and do our math, and then comes out exactly at 20 milliliters per hour. And so this is our second answer. We are going to give them the maximum of 1,000 units per hour, and that will be 20 milliliters per hour. 6 hours passes and we draw the blood and we send it to the lab and we get an APTT result, which is an activated partial thromboplastin time. So that is a blood clotting value letting us know how our patient is responding to heparin. So we're going to look up 75 in our protocol to see how to proceed. So when I find 75, it's in this range, and it says that I should decrease the infusion rate by 2 units per kilogram per hour. So I'm going back to my problem. And it says find milliliters for the bolus. And so in that protocol, no bolus was requested or ordered. What we have happening here is that it's taking them 75 seconds to reach that clotting level. And that's a really long time. So our patient actually has too much heparin. That's why there's no bolus at the 6-hour mark, because we don't want more heparin in their blood. We actually want less. And then we're to find a new milliliter per hour rate, and when we read the protocol, it said to decrease by 2 units per kilogram per hour. Now, in the previous problem that we did, we were able to add that 2 to the 14. So our temptation here is to take this 14 and subtract 2. The issue is that we never gave the 14. We had reached the conclusion not to give that, but instead to go with the maximum. When I look at the amount that we did give, we gave them 1,000 units per hour, but that does not have the same label as this 2 units per kilogram per hour. And in math, we can only add things that are like terms. These are not like terms. They have different labels. So what I'm going to do is to multiply by the kilograms in order to get a label of units per hour. So I'll set this up. 2 goes on the top, 2 units per kilogram hour. And I'll multiply by their kilograms of 96.4. So that allows me to cancel the label of kilograms, and doing my math on my calculator, I now know that we are going to decrease their rate by 192.8 units per hour. So I want to take my 1,000 that I originally gave them, and that was units per hour, and I want to subtract, because I want to decrease it, the 192.8 units per hour. and that will give me a new amount of 807.2 units per hour. So that is how much I want to administer. And I have to figure out how fast should I set the IV if I want to give 807.2. So I'm going to use the same med that I did before. The med on the IV bag had every 1 milliliter contained 50 units. So I set that up so that it cancels. So the label of units cancels out, and I do my math, and I'm going to round my answer to the nearest tenth so that I have something I can type on my IV pump. So I have 16.1 milliliters per hour. In this part of the problem, we see something really important. We have to only add or subtract with excuse me, got tongue-tied. We see something really important. We can only add or subtract when we have matching labels. That is why we multiplied by the weight first to get to this label of units per hour, and then we could do the subtraction because we knew that we were giving them 1,000 units per hour. We wanted to decrease that. We subtracted and we got the 807.2 units per hour. Then we were able to convert that over to milliliters using our IV bag. We rounded to tenths. So another 6 hours goes by, and our patient gets a new APTT of 63 seconds. So let's go look at our protocol. 63 seconds is in this range, and our direction is no change. So if we go back to our problem, find the mLs for the bolus. There's no additional bolus. And then it asks us to find the new ml per hour rate, and we're going to have our IV continue. At the 16.1 because it said there would to be no change. So continue at 16.1 mLs per hour. And so we completed our entire problem.